And next up, looking for Najib Ahmad for our keynote. Excellent.
Thank you much. Wow. This is awesome to see Nanoc grow this big. It's been kind of an interesting morning for me. I haven't done one of these at Nanoc for a long, long time. I can't even remember the last one I actually did. And so it's really fun to see 1,000 people, maybe not 1,000 in the room, but 1,000 people registered. So congrats to all the people that work on making Nanoc successful. It's been a constant in the industry. It's really fun to engage. And then also seeing AS701, my former playground a long time ago, back up on the net or on the screen was really fun. Wanted to kind of talk a little bit about the past and future. I was kind of surfing LinkedIn for some reason, and I saw an article or a post by a network engineer asking what are the skill sets required for network engineers in the future. And obviously he had a blog and he listed about 5 or 6 different ones. All of them made sense. And then that got me curious and I started looking at what other people say are the skills required. I ended up finding all sorts of things which were sort of all relevant. Was really happy to see soft skills as well listed in there. And there was this picture too, which for a second I was like, wait, what is it trying to tell me? Be her and not her. And then I realized that at the bottom it's actually the puppet. And so you want to be the puppet master and not the puppet. Was kind of really strange analogy for a network engineer and the skills. I've been lucky enough to actually be involved in networks that have been scale networks. And one of the things that I learned that scale gives you problems that you haven't seen anywhere else. And it requires skills that you probably don't get anywhere else if you don't watch or you never actually work in scale. So I started thinking about what are the skill sets that we actually at Facebook try to encourage and the approach that we try to take. And there's been a key fundamental thing that I want to talk about, which is operations first mentality or operations first thought process. But to give you some context, let's do a little bit of the scale conversation. I'm not going to spend too much time. Facebook is all about scale. There are over 2.2 billion subscribers, but that's just Facebook. If you add WhatsApp, Instagram, Messenger, you're well over 5 billion users. Obviously not all unique, but still you have to worry about individual users and their sessions. Tons of photos, videos that get uploaded every day. Obviously we have to replicate them and make sure that they're never deleted or lost. 1 million plus status updates, comments. The more interesting thing to me is how it's done. So if you actually click on a post on your phone, what actually happens? First, obviously, it gets to a data center somewhere in our domain. Then what happens in the application side is the interesting part. Facebook is a mini app or mini service type architecture where a lot of these applications actually talk through a communication protocol called Thrift that we invented. What all that means is there's a lot of network traffic that actually goes back and forth when you actually click on a post. When you want to see something, that's actually computed on the fly. So very, very heavy dependence on network to actually show you something like this on your phone. Ultimately, being able to show this to anybody, anywhere in the world is really a tough problem to solve. So what is operations first mindset? That's one of the key principles that we use in how we design, build, and deploy and manage networks. Automation, everybody talks about automation. That's just a given. We came up with this slide about 5 years ago. Engineer builds robots and robots manage the network. It has actually served us really well. Today, if a line card fails in our environment, no engineer has to really move and do anything about it. Software detects it, mitigates it, and we move on. So this philosophy of automation has really helped a lot over the years. We started with the more automating CLI conversations a long time ago, and then pushed the industry to get to really APIs and programmability, and things got a lot better. And we're starting to make progress there. It's really awesome to see Juniper host a hackathon at Nanog, which is a big change from that philosophy of being in a CLI world to actually programmability. This is where we want to get to, but here's the bad news. Automation doesn't really get you there. Yes, it will solve a lot of little problems, and you can go faster and deploy more things, but you're really building in a ship or an aircraft carrier is what you're trying to do. Automation doesn't really get there. So one of the key things for us is that we want to think operations first and features second. If you're building at scale and you can't actually operate it, eventually you're going to fail. And operating it really, for us, means operating it without actual human intervention, for the most part. The more human beings you require, it will take you a lot more time and effort to actually troubleshoot problems and actually be able to figure out how your environment is behaving. One of the things that I used to worry about as we continue to grow and scale is, hey, is there anybody who actually knows the end-to-end environment? Because the systems get so big and so complex that you don't actually have any one individual that knows the entire stack of things that are required to show somebody a post. And in that environment, how do you do troubleshooting? How do you figure out what's going wrong? So we started thinking more about building systems that actually are different. It's funny that AS701 came up, which is one of the examples that I was thinking about, fail-proof versus fail-fast. We used to build stuff that was fail-proof. Example, I remember back in the UUNet days, we tested a release of software by a vendor for 18 months. For 18 months. To test it, to deploy it in our production environment. And we kept failing. Every time we got a new release, we kept failing. I think most of you will probably recognize this. We deployed 12.0.23. It started at 12.0 and went to 23 before we actually got our deployment. That 18 months, all we did was spend time in the lab testing and testing and testing and testing. That was one approach. Today, we wouldn't do it that way. We would actually spend those 18 months building detection capabilities and mitigation capabilities and deploy code that is not as well tested, but to focus more on detection capabilities so that we can actually get done a lot faster or detect failures that do happen with the software and be able to mitigate them faster. So building something that actually doesn't fail is actually a misnomer. 3 things are guaranteed. Hardware will fail, software will have bugs, people will make mistakes. How you survive that is really what the operations first mentality is. You need to be able to survive those failures. And we all started up in the world of building stuff that never failed. Things like 5 nines or 6 nines. We actually don't worry about that. We never measure what our nines are, because the whole idea is to be able to detect failures and mitigate quickly. Can you do that in 1 second or less? We do that in some cases, and in a lot of cases today we still don't. And that's one of the things that we're working on. How do you get there? We get that through iteration. We don't try to build an architecture that is fail-proof. Again, the same conversation about building an architecture and worrying about it for months and months at a time before you actually go deploy it tends to not get us the result we want, because by the time we've actually deployed something, the problem has moved, or more technologies available to solve different problems. We take it seriously enough to say there are no architects on the team. We do a very you build it, you own it type thought process, where any team or any individual, any engineer that builds or designs something, they own it, and they do the on-call for it. And on-call is where we learn. And that's how we continue to sort of improve over time. So this is something that we've fought over the industry for a long time. I remember 5 years ago trying to hire senior engineers, and they would be like, oh no, I don't want to be on call, I don't carry pager, been there, done that, not my thing anymore. And we would say, okay, thank you, but no thank you. And we would move on. It was really, really hard to hire senior network engineers. That is changing slowly and gradually. But that's the mentality that we use, that you build a system, you don't have to be perfect, deploy it. As long as you have enough detection and mitigation capabilities, you will do okay. And you'll learn and you'll iterate over it, and you'll get better over time. How many of you have legacy? That's the one thing that I hear the most of the time. And anytime you talk to any other network, that's what I hear most, a lot of times, that, well, you have no legacy and we have legacy. Well, one of the things about legacy is, like, we are also now 14 years old, so it's not like we have one generation of technology in the network. But legacy, most of the time, people make it a crutch. Oh, I can't do it because of legacy. You have to really, really weed out legacy over time and pay the TED. So one of the things that a lot of engineering teams do at Facebook is we run this thing called a tech debt week. That every 6 to 8 weeks, teams call a tech debt, they do it themselves, and then go clean up of whatever it is that they're worried about, whatever it is that we kind of put a patch together and didn't really clean up after it, or we think it's not going to work or not going to scale, or we've been doing it manually, how do we go fix it? We take a week out and we just do that. Tech debt, the entire team worries about that. And all projects are on hold for that week. And then we continue to move from there. So that's one of the things that you have to consistently think about, on how do you continue to pay down the tech debt as you go along. If you don't do that, you will hurt over the long term. So a real example of operations first thought process. We remember Sandy. Most of network people should, right? Because a lot of trouble happened in New York because of Sandy. We had some issues as well. One of our POPs was flooded. So after Sandy, we started looking at saying, if Sandy had actually gone a little bit south, we could have been in bigger trouble. This was back in 2012. We had about hundreds of terabits, 10 megawatts of capacity, and thousands of servers in the path if Hurricane Sandy had just gone slightly south. So the question then became, hey, what would happen if we lost the entire facility? If this went dark, will we survive? And we couldn't actually answer that question day one. So we started to think about how we were going to solve this, and we came up with this project name called Sandstorm. The Sandstorm was, the whole idea was, we're going to turn off a data center. Tens of megawatts of capacity, tens of thousands of machines, we're going to just turn it off and see what happens. It took us almost 2 years to plan that exercise. Almost 2 years. And the day we ended up actually thinking about the day then we were supposed to do that, we had a war room, we had a bunch of people sitting in a war room. My boss, Jay, who is head of engineering and infrastructure, he was talking to the CFO that morning, and the CFO's like, well, awesome, you guys have done a great job of planning this thing, but you're actually not going to turn this off, are you? And Jay was like, no, we're going to do it. We're definitely going to do this because we've planned it, and the only way we're going to know it works is when we turn it off. Guess what? Even after 18 months, over 18 months of planning, and this laundry list of automation of work that we did, we still had to give exceptions to several different apps and services that were like, wait, we can't live without this one data center, so you can't turn it off. And so we had to give exceptions, and we did that. In the end, it was successful, and this would be a normal event where you had a problem where you see all the choppiness of the traffic flowing between facilities, ends up in direct user impact, and this is what we really actually want. When some facility goes down, others pick up, and there's less noise in the environment. So we actually got that to happen, but as I said, it took almost 2 years of planning and a lot of exceptions given to a lot of different services to make that happen. So what's next? Well, what we learned out of that exercise is 3 things. One, you got to have a commitment. You got to commit. Spending that kind of effort and time for over 18 months, building automation, building tooling, is important. If you don't have the commitment, you're not going to get there. And I hear this all the time, well, management will never support it. That's the thing that you have to really figure out how you're going to get the commitment. Tooling is really, really important, especially things like data collection. Human beings tend to be really bad at that. It's easy to write software to collect before and after snapshots and do analysis and do all sorts of event correlations and come up with data. And then you really have to figure out how to embrace failure. This is one of the things that as an industry we've struggled with, is how do you embrace failure? Again, going back to we try to build fail-proof stuff and not try to build stuff that fails fast. And embracing failure is a fundamental part of the operations first mentality. So what would you do if you weren't afraid? We did a bunch more storms. We started doing them every 6 months. Trying to get better at what we do. And we take each facility and we would turn it off. And we try to minimize the time it actually took us to plan that event. The real fun part was once we got through all these firestorms and actually turned a facility at a time off, we're like, how do we do this? So we came up with this new tool, a dice. And we put a data center name on each side of it. The way it would work is Jay would throw the dice, pick a data center, and he would give us 48 hours to turn it off. And we were like all excited. This was fun to do. We learned a ton of things from it. The only problem was it's not a scalable solution. Pretty soon we have more than 6 data centers. Crap, the dice doesn't work anymore. So random generator at that point. So what did we gain out of this exercise? Tons of learnings. That's really the first part. You don't really understand your dependencies. The first time we turned the first data center off, we didn't realize that all our monitoring was in that data center. So if you turned that off, you're blind. You may be running, but you don't know. And you can't really get there until you turn it off. So do it. The simple things which are intuitive, where when you turn something off, traffic will shift. Do you have enough network capacity to handle that shift? You may have enough capacity for steady state, but you don't have traffic capacity enough often for transitions. And you may get into a race condition that you never survive. And that happens a bunch. So there's just a ton of learning in terms of understanding what the environment actually looks like when you turn it off, when a particular facility or a particular system that is actually not available, what happens to the rest. Obviously cannot survive without automation. You do more and more automation. That is a fundamental, They said that started 5 years ago in the network world for the most part. And if you're not there, you're missing the boat. Get there. Start doing more and more automation of pretty much every function that you have. But this is something that all of you will love. This is the number 2 complaint that I hear from most people. Well, you have better apps than we do. Or our apps are legacy apps. We won't get there. The only thing is that if you start turning data centers off on them, they will learn. They're not dumb. They just have different priorities. You change their priorities. That's all you have to do. You have to force them to think about it. I remember the first storm that we did, our IT folks were like, whoa, sorry, not going to happen. We're not. This is company critical and all that. We gave them an exception. Now even IT doesn't get an exception. They live in the same data centers. IT, which runs Oracle and things like that, they don't get an exception either. They turned off. So you do start getting better app behavior or better developer behavior from all sorts of constituents that run on top of your network. And that's really important for long-term resiliency of building these environments. Faster, more predictable recovery. That's obvious that you have a system that actually behaves better because you have tested it. Let me give you a real specific example. We call our outages SEVs. And every big one gets a name. This one was called Tree Down Sev, because a tree took it down. Literally, a tree coming down caused a problem for us. It was a dual failure that took out enough capacity to one of our facilities that we started seeing trouble there. And the way we solved it was we started getting every service, every application on the phone or through our messaging system saying, hey, you need to move away from Forest City data center. Within 20 minutes, all services had moved off, all through automation. They run scripts, they run tools that drain services to other facilities. Within 20 minutes, all services moved away from Forest City, and all life was back to normal without Forest City being in the path. It actually took us 8 hours to fix the actual underlying network problem. And if we didn't have these storms and we hadn't tested it, it would be an 8-hour outage. So the question for you, would you take this 20 minutes of choppiness and everybody moves off, or you would take an 8-hour outage? That's really the difference in the operations first thought process. One of the examples I use sometimes is, hey, if you're an operations center and you have one 20-minute outage every month and a bunch of people have to jump in to solve that problem, or you have 20 one-second outages that nobody does anything, which one would you take? And almost everybody's like, yeah, I want the 20. People want more outages if they're short and are mitigated very quickly. And that's really what the operations first thought process is. How do you get there that you can actually detect any failure and mitigate within a second? So what's next in the disaster recovery conversation? We do these disaster recoveries for our data centers and our regions, but we have POPs all over the place as well. And POPs are a different problem because they have a bunch of ISPs that we connect to in that space as well. So if you take a POP down, we're actually causing a lot of traffic churn to all our peers and all our partners on that side. So this is actually maybe even a call for action is we want to test each and every POP and turn it off and understand user behavior, understand user experience. And if you want to partner with us, we'd love to kind of do that because the POP disaster recovery has to be done for both sides by coordinating with the ISPs. So we can't just do it unilaterally on our side. So we don't want to cause that much churn on the internet as such as traffic-wise. So if you see any Facebook person and you're interested, go talk to them. There are several of us here who would love to engage in trying to figure out how we actually get a better sense of POP failures and what happens when POPs fail. All right, so to sort of wrap it up, automation's key. Continue to focus on that. Automate everything you can. The step that we learned a lot is understand your dependency, understand your dependency tables. This is really critical as you scale and your services start becoming really, really complex. You need to understand that dependency, and you have to validate. If you don't validate, you actually don't really know. You can do all the validation on paper you like, but real systems don't behave the way you think they do. Until you actually test them, you will not know. So those are the three things that we do over and over again, and that's a mindset, not necessarily a skill set. Thank you very much. Questions?
Thank you, Najim. Matt Petak from Oath here. Love the talk. At the end there, you talk about doing the pop failure testing and then kind of said, well, we don't really want to do it for real because that would be too disruptive to the internet. I think the whole point of your talk for the whole first part of it, though, is if we don't actually dive in and take the plunge on those, you're not really going to know if your simulation or your ISP by ISP test really works versus just saying, hey, Nanog mailing list, this Friday we're going to take down our pop site for 12 hours. You're going to see our BGP neighbors go down. When we're done, let us know if there's problems and we can work with you to fix it, but we're going to do it. Is that something that you think you might just dive in on?
That's exactly what we intend to do. We'd love not to do it that way. We actually did one already. Alex is here from Facebook. He can tell you all the details. He's raising his hand over there. So we've already done one, and we have a lot of learnings from that. We actually do intend to do that, but it would be better if we had a partner on the other end as well, and the partner wanted to test their abilities of traffic shift as well, because traffic will shift on their network as well. So ideally, we don't cause all sorts of havoc on other ISP networks by doing RDR tests and notify and partner. But if you don't, much like IT, we'd be like, sorry, we're doing it. So
Gotcha.
that will happen, yep.
Thank you.
Sure.
Hey, great talk.
Hey.
I have two questions. The first one is about how did you do the shutdown? Was it at network level with, I don't know, traffic shaping? Did you use IP tables?
There are different levels at this point. Mostly it's really shutting down the network level. We started with a simple put ACLs in and block traffic away. And these days we can actually do all sorts of different types, because you do want to actually look at individual specific failures and try to mimic as many as you can. When you start with the simplest that can be reversed very quickly if you get into serious trouble. And as you get better and better at it, you want to do more destructive or disruptive type failures. So try all of them.
All right. And the second question is about communications. How do you send this idea at the beginning to the rest of the company? Because you have to change their mindset. Was it an email sent to all technology? Hey, we're shutting down.
Emails usually don't work. Over the 18-month period of the first one, we had lots of meetings, we had lots of posts, lots of group posts about this, a lot of Q&A type sessions on, hey, what's going to happen? And then you also start actually doing digging, not just on the network level, but also at the service level, and really start understanding dependencies and go talk to those groups and saying, hey, we think these are your dependencies. How are you thinking about these? So you actually start engaging with individual property group, individual services, and make sure that they understand their environment a lot better. So it takes a lot of work in the beginning to actually get there. You do want to give the other groups that feeling that you actually are there to help and you care, rather than I'm a bully, I'm going to pull the plug out and deal with it.
Hi, Tony Tauber, Comcast. Nice presentation. I was wondering, so you said that you actually did this failure already, right?
Yes.
And maybe I missed it, but did you say like when and where it happened, so that maybe other people can look back and see, okay, how did it impact us, or
Sure.
I think that might be instructive.
I'm not sure we can actually publish the dates, but I'll check and see if we can actually publish the exact dates. I already listed the months in that slide. that the individual storms were. And individual storms were essentially, we took one of our facilities down and took it offline and essentially be able to run with the rest of the machines that we have in the environment. So ideally, you would not have seen any churn other than maybe a blip of traffic moving around. But I can check and see if we can publish those dates if you're interested in doing that.
Yeah, I think it would be helpful to people.
Okay, cool.
I thank you. I love the tech debt idea, tech debt week, you called it, right? How do you handle budgeting when your tech debt week requires the legacy environments to have hardware replacements? Do you have like a percentage every year that you set aside for that?
We don't really budget based on tech debt per se. The priority is essentially based on pain threshold. Whatever's more painful, we'll do that. We tend to take the philosophy that we will deal with the pain more than we will build new features. So I would much rather drop a new project and go solve a debt problem and a painful problem rather than actually build more stuff. Because the more stuff you continue to build, the more pain it will be. And in the end, nobody wants to be on call at that point. So it's a self-fulfilling sort of prophecy if you get stuck in that model. So there's really no easy answer. I do sympathize with the network shops that are considered cost centers because they tend to be really, really marginalized on a cost basis. And I think that in the end results in a bad answer long term. So this is up to the leadership of your sort of team to figure out how they're going to pitch what the right answers are for your environment. But as I said, it's a matter of prioritization. It's the operations first, feature second, that conversation. So instead of building a new feature, we fix operations first.
Thank you.
Yep. Awesome. Thank you so much. Appreciate it. There you go.